Hey folks, thanks for coming out this afternoon, appreciate it. Very happy to be sponsoring this event. Just wanted to give a quick talk on what we do at Inference AI. It'll just be a quick minute. Yeah, so we've been around for about 7.5 years or so. As you can tell by our name, Inference.ai, we do something inference. And yeah, in fact, we do everything inference. So if you're burning tokens for your business, if you're running closed source models, open source models, we can immediately get you some very steep discounts, whatever you're doing. If you're running your own models, we have GPUs. We've been in the GPU business for a very long time. On-demand clusters or reserve clusters. And yeah, on top of that, we also have our own agent platform. So the idea is that, I think about 80% of the people when they're trying to run OpenCloud or Hermes, they get blocked out by the first step, which is, should I run it on the cloud? Should I use my own computer? Should I buy a Mac Mini? Which is actually a very difficult problem. So, being an infrastructure server company, we try to solve that problem for the clients. And yeah, we basically help you one-click deploy on our own servers. Everything is free. We charge you nothing for the agent, so you might as well try it out. We have our banners outside. Feel free to scan the QR code. Yeah, you can one-click deploy Hermes, OpenCloud, or whatever other agents that you have. Yeah, so if you guys are running any sort of personal project, businesses, come talk to me. I'll be over there in the corner. And we also got our own booth in the other room with a few folks here. We have our own banners outside. Yeah, so looking forward to talking to you guys. Thanks.
Okay, so we're back on track. Back on track. So first panel for this afternoon will be about optimizing inference. I believe a very relevant topic, given that we are trying to put as much AI out there in the real world. And I want to invite Will Horan, the principal from Geodesic Capital, that will be moderating the panel together with. He will introduce these speakers. Will?
Thank you so much. Awesome. I'll take the cool student chair over here. Thank you so much. Okay. Well, thank you everyone for joining us today. My name is Will Horan. I'm a principal with a growth fund in the Bay called Geodesic Capital. Super excited to have the conversation today about what I think is one of the most interesting and ubiquitous and at times hotly debated topics in AI right now, which is inference, and specifically inference optimization. Just to set the stage a little bit, I think we're all probably pretty aware of this topic, but in the past few years, a lot of the conversation was around training, right? Pre-training these large models, huge amounts of compute, huge amounts of data, huge model sizes, right? In recent 6 to 12 months, workloads have shifted a bit. Inference has become the bottleneck for deploying AI. And so we think it's super relevant to have this conversation today to talk about what that entails and what are some of the trade-offs there. I think people have probably seen all the headlines. The cost of intelligence, to serve tokens from equivalent models a couple of years ago has fallen something like 1,000x. And yet we see Uber blowing through their quarterly budgets and putting $1,500 caps on people because they're just spending too much on this. So we're going to explore that question among others in terms of why are the costs going so high? What does it take to actually run inference at scale, economically, securely, and reliably? So with that said, I'm going to do a quick intro on the panelists here, and then we'll jump into it. So what's really nice about this panel is we have folks from across the stack. We have Chi Jin from Cerebras on the hardware and software co-design. Ash Lewis from Fastino on task-specific models. Nikola Borisov from Deep Infra on production serving and infrastructure. Eugene Chia from Featherless AI on open model access and inference. And Denise Tang from Gradient Ventures on the market and company building lens. So with that, let's jump into it. We're going to do a little lightning round to start things off. I didn't give the panelists a heads up about this one. I'm going to ask you all for just a one-sentence worldview. What is the single biggest lever for making AI inference cheaper or faster over the next 2 years? Is it hardware, software, the model architecture, or something else? So maybe we'll just run down the line here. Denise, do you want to kick it off?
Yeah, I think my one-line answer will be inference software layer optimization, meaning you might have custom inference engine per model or per model architecture. I think because we're all waiting for the hardware to take another couple of years to be fully ready. So I think the immediate value add for inference optimization is definitely in the software layer.
Nicola?
I think the biggest gain could be from clusters that are designed to do inference. Like all the compute that's currently out there is basically training clusters roughly. So inference is quite different, and building optimized clusters for that would be great.
Hello, my name is Chi. My view is, again, it's probably software, hardware, co-design. I think right now the GPUs are pretty good at the preview, and then servers and other guys are pretty good at decoding. I think if we have a software layer can run the mixed things, you can get the best of both.
Hi, I'm Eugene. I work on the open source linear architecture, RWKV as well, on the research side of things. So different architectures do show the promise of like cutting inference costs by 100, 1000x, and that's like one area that we are spearheading on. Rather excited about that. But I'm going to contradict myself. I feel like the biggest lever is actually model size or smaller sizes. You look at the 31B, it already beats like GPT-3 and 4.0. And the future 31B is going to beat GPT-5. Like going smaller than what you need is going to be like the huge multiplier effect.
Yeah, thanks. Yeah, my name's Ash. Yeah, I mean, I agree. So I think like it's really hard for us to be influencing what's going on hardware, like unless you work at Cerebras. But most of us just have to wait and see what happens. And on the inference engine side, inference engines are really good, right? So if you can just use a smaller model, that's usually the answer, at least. I mean, even if it's not a smaller model, if you're using Kimi K2 instead of Opus, it's still like 75 times cheaper, even though it's only a third of the size. So probably just model selection is the most immediate thing that we can do.
Great. Okay. Yeah, we're going to explore that particular question a little bit later in terms of model size. But so let's take a step back and just talk about kind of the why now, right? Again, it used to be very inference or training focused, right? Now everyone's focused on inference. What has caused that shift? Is it the infrastructure build out that has enabled it? Is it the agentic token heavy use cases? Is it just adoption and deployments? So yeah, maybe Denise and then Nicola, if you guys could chime in, that'd be great.
Yeah, I think for me, it's definitely the adoption. It goes without saying. We're all using AI nowadays. It's more interesting to also think about like why and how does the adoption really improve or increase the usage for inference. I think 2-3 years ago, on the frontier is always, from a closed source model company. But in the last 2 years, a few things changed. For example, the model maturity increases, and also the open source model became more available. Performance goes up. Availability is always there in all the repository. And on top of that, a lot of amazing inference company, no matter serverless or inference as a service company, they enable open source models to be adopted faster. And meanwhile, in the developer tooling ecosystem, also getting more mature, we now have all the framework, observability and eval, memory management, sandbox isolation, all the tooling to allow, along with the open source model, to allow all the agent builders to create more agents. So nowadays, number of agents increases, hence the inference increase. And a little bit more details here is even the number of inference call per task increases too. Nowadays, you write a prompt, and behind the scene, there are multiple inferences tool call got triggered just because the multi-agents orchestration, and on top of that, the long horizon agents, I think multi-sub agents, these architecture really enable just more inferences happen per prompt. And even you look into individual inference call, there's also a large amount of the context window increase that really just drive additional tokens to be processed, to be generated. So combine all these together, it's like a chain of reaction, right? You have more agents and more inference per prompt and more token per inference. Combine all these together, I think that's the reason why inference became more important. And the last point here is really the training and the inference became closer nowadays. Traditionally, it's pretty separated two workloads, but we're entering the post-training era because of RL. So a lot of the rollouts is essentially the mini inference, and a lot buffer reward model generates, eval metrics. These are essential for the post-training pipeline as well. So as more companies enter the post-training era, I think inference will continue to be relevant, even to enable the trainable data for their post-training pipeline. So these are the reasons why I think inference became way more important than before.
Yeah, any other thoughts on that, Nicola?
Yeah, I agree with all of what you said, and I think it's kind of natural. Like, we keep improving the quality of the model, and we need, like, at certain point, this quality kind of goes above, let's say, like what you need for good software engineering. And I think we crossed that actually in the last 6 months. Like, I think 6 months ago, you would still use autocomplete and things like that, but you wouldn't be as heavily reliant on the agents. And now I think even the best software engineers almost don't write any code anymore. And so that's just because the quality of the model, but also I think how the models got trained towards the agents kind of we really crossed that point. And so the demand has really been very, very high. And
yeah. So it sounds like it's essentially adoption, and it's adoption not just because the models have gotten good enough, they've gotten so much better, but it's the specific use cases are agentic and more token hungry in nature, and so that's kind of driving the boom there. Okay, let's talk about the cost trade-off, right? We talked about, and I think Ash was touching on this as well. The cost of intelligence is falling precipitously, but people are blowing through their budgets. So as infrastructure providers and investors, are we actually making AI cheaper, or are we just enabling people to consume more of it? So maybe Ash, why don't you kick off, and then Nicola might come back to you for that.
Yeah, it's interesting. So for the last couple of years, we've always asked our customers, what do they care about most when it comes to buying models? And the answer has always been accuracy followed by latency followed by cost. And literally in the last 2 months, that's completely changed, and now cost has become a factor. And I think it's because now models are actually just good enough. So now we actually need to care about how much they cost. And I think, I think to Denise's point, right? It's this idea that now when we run, back when we used to run a prompt into GitHub Copilot, it used to just give us a single response, and it was really easy. Now if we run a prompt into Claude Code, it's like hundreds of thousands of tokens for everything, right? So it's just became really expensive all of a sudden. So yeah, I think cost has suddenly became a big factor. Yeah.
Cost has gone down very dramatically. Like, I remember when we first, the first good open source model was like Llama 2 that was kind of commercial, and that was like $1 a million tokens, and like now we have much, much better models at like 5 to 10 cents per million tokens and cash tokens. And so I think the agents really increase the usage, right? Like, if you're just going to do autocomplete or chat with ChatGPT, you have to read all these tokens. Now, if you basically ask Claude to do something, like, there might be like 5 million tokens happening in the background in a loop. And so I think it's a normal curve, right? Like, the cost goes down, but because it's kind of a nice thing, like, it's helpful, we use more of it. Now, sometimes we might overdo it. Like, maybe there's stuff we shouldn't have used the AI for to create something. So I think we're going to adjust, but it's normal.
Okay, that's actually a perfect segue, thank you, into the next question, which is, asking the question of, do we need Opus 4.8 fast to summarize my emails? Do we need these large models for most use cases, or is it better to have task-specific or small models doing a lot of the work for us? Are we just over-provisioning intelligence as an industry, and if so, why aren't more people correcting for it? We have seen headlines in the last couple of days, actually, of some people starting to take this more seriously. But I still feel like a lot of people are burning through tokens just for the sake of doing that. And so, maybe Ash, Eugene, and Chi would love to hear from you guys on, the large model versus small model kind of use cases.
Love to maybe take a crack
Sure.
at this. I mean, at least from what we see, right? So the way people measure the priority is actually intelligence first, capacity second, costs last. The main reason is if you can produce the values, we can always see people want to go to the higher intelligence thing. And then after that is like, I want to do a lot of work. You guys don't have a capacity. How can I get more? And the cost, when you get to cost, is typically like, if you couldn't figure out what your value is, and you start to think about, am I like spending the money, right? So I have two things. I'm firmly believe, not we, I'm firmly believe that the large model is the way to go. It's just because from what we're seeing right now, it's a couple terabytes. I think, sorry, a couple trillion links. I think the human brain have 100 trillion. I think if you got into the 100 trillion, then you got a human brain, and then we're talking. I actually feel like, unfortunately, we tried all the smaller model. It works in some narrow situation, but I don't feel this is a mainstream. So, but anyway, we should obviously as a hardware guys, we want people burn more tokens. Obviously, I'm biased.
Yeah, Ash and Eugene, I feel like you guys might have a different view on that, so I'd love to hear.
Yeah. So on our side, like one thing that we do rather differently as a provider is that we host the largest collection of models, around 40,000 models. We're trying to scale that to all 2 million models. And we see, and the key thing behind it is we see models for specialized use cases, specialized languages, and so on and so forth. And it's back to the point actually, like, do you want to use an Einstein to summarize your email? It kind of doesn't really make that much sense. And if anything, like, sure, they will definitely be used for Opus or Mythos for the hardest challenges. But on the flip side, right, what people want for the vast majority of day-to-day tasks is actually just reliability. Like the model to just get that simple task done more consistently. And we've been seeing more and more companies fine-tune RL, even just smaller models like 27B, 31B class models, do those tasks respectively. And when they do such a fine-tune, they run billions or even trillions of tokens in that one task. And it's just about unit economics of scale where it just starts to make sense at volume.
Yeah, so just a background story on how we started Fastino. My last company, we kind of went viral with a dev agent product called DevGPT, and we ended up spending about $2 million a month on GPT, before GPT-4 came out, actually. So we fine-tuned a bunch of small models and then got that bill down to about $20,000 a month and realized that that's probably something that people care about. Now, I think this is a solved problem, meaning that I think that really good enterprises already do this today. They start with a large model and they inference the large model, and then slowly they'll start fine-tuning small models and routing inference towards it. The problem is that's pretty difficult to do. Like fine-tuning, also no one's excited about fine-tuning, I have to say. Like, you know, I mean, the truth is, I mean, we've tried to sell a fine-tuning product as well, and it's like no one wakes up every day and they're like, yeah, I really want to fine-tune a model today. Like, it just doesn't seem to be a thing. Our approach to this is we give inference for like a large model, like an Opus, and then we partition the Opus inference into smaller buckets and fine-tune all those buckets through an agent. But yeah, I think it's a solved problem if you've got a team of really good MLEs or PhDs, but it's just a difficult thing to do, is to fine-tune all these small models. But I think it's the right approach.
And maybe I'll pull on that a little more. Maybe back to you, Chi. Are there certain use cases that you feel strongly are better suited for these large models, or what do you say to Ash on that in terms of why not just fine-tune, right? Especially given the open source models have gotten quite good. If you can fine-tune them with your own data, is the performance comparable?
I think the way, by the way, I worked back in Google and Stripe and all different places. The way is, you think about the AI, right? Before this generative AI, there are a lot of AI use cases, right? There are a lot of ML use cases, but they all seem to be specialized. And part of the reason is to make it work, you have to create the data, you create the context. You can say, you could only perform this way, in that way. What I think this rounds of change is basically, there's a lot of tasks you can actually change it to be AI major, human minor. That is where we are seeing, like where the people actually got a lot of value is they're no longer doing coding, they're just review the code. Maybe they don't even review the code, they just review the output. I think the issue, what we're currently seeing is majority of high value tasks is all about the judgment in a very, very complex environment that you will not get wrong. So if you have a narrow environment, you could actually do it without AI. So I actually feel like it's just what it is. I think the hardware, whatever, we will make this thing cheaper, and so everyone can get more intelligence. That's my view. So yeah.
Okay. Yeah, I'm going to riff off that a little bit in terms of the hardware that's on the market right now, right? So NVIDIA, all very familiar, but there's lots of other accelerators and ASICs that have come out, right, that are quite capable, right? Obviously, there's Cerebras, you may have heard of that company. There are TPUs, Trainium, all the other chips that are on the market. From a practitioner perspective, maybe for some of the folks in the room, should they care about the hardware under the hood, or should it all just be abstracted away for them from a software perspective? Does it really matter? And so, Chi, I'll give you the first word, and then maybe Nicola and Denise, if you guys have a view on kind of the hardware-software dynamics.
Every time when the industry started, you sort of care hardware. If you think about it, there's a CPU, right? And then after that, there's a GPU. And the reason is GPU does large-scale computing on a high bandwidth memory pretty well. And then you have NVL72 with the links. And then the pieces Cerebras was doing is just a memory between memory and the compute, right? But the people above us, they don't really care about all the mumbo jumbos. And then in some way, we first will all partition our work stream. At some point of time, the cost and complexity become an issue. The software would actually over inference us, say, okay, here's the inference. I do not care. That's why we have a disaggregated inference. That's why we have NVL72 links. That's why we have, I think what happened is, right now you care just because the hardware guys and the layer's not good enough. At some point, you don't need to care. You just I need X gigabytes intelligence. Please give to me. I'll pay you. So something like that.
Okay. I wanted to chime in on this one because
sure.
When we first launched our platform, and considering our research background, we talk about, we are providing you inference, and all this is powered by RWKV. We optimize it, save you money, 10x cheaper, speculative decoding, all that. It actually lowered the conversion rate. Over time, if you look at our website, we just go straight to the point. You want this model? What's the price for it? This is the token speed you get. That's all people really care about. As much as I want people to get rid of transformer attention, for example, and my research being in Quant, gated delta net, where it's 3/4 non-transformer, most of my customers don't care. They just get the intelligence, they see the price, they get what they want. They just know the model. That's it.
I think from my perspective, the hardware is really important if you're gonna actually do the inference. And we're an inference cloud. We set up data centers, we buy different hardware to do the inference. So that's really kind of a big portion of it. You can't not care about it if you're gonna do the inference. Now, the goal is for us to make it so simple and easy for people to consume the tokens on the other side so that they don't care. But there's a lot of things that go into this, like the price of electricity, the data centers, the different accelerators you can do. And I want to just mention this one thing, generating a single token from a 100 billion parameter model requires hundreds of billions of mathematical operations. And fetching something from a database, one row, it's only 1,000 instructions or 10,000 CPU instructions. So similar tasks, AI tasks are hundreds of millions of times more intensive. So that's why all this talk about data centers and accelerators, the hardware is important.
Yeah, the last thing I will add, because I think the panelists pretty much answer my answer as well. It really depends on the persona and who is deploying the AI. It can be agent builder, right? If agent builder is deploying AI to their customer, I think it's really similar to what Eugene was mentioning. They don't care. They care about the model routing. They care about pick which model that perform better. They care about the agent harness. They care about the inference from picking inference providers' perspective, not necessarily the hardware behind the scene. Because again, they still care about the ROI of the cost. However, again, it's to justify the ROI for their agents' final unit test versus really figuring out what the real hardware behind the scene really is. But today, if we're talking about the person who is deploying AI is the infra engineer who is working at the inference as a service company, the inference cloud company, or the enterprise who actually has the full stack agent internally. These infra engineers, of course, they do care about hardware. They first of all care about if they can get the right hardware they're looking for. Once they get it, because it's really scarce, very difficult to get a large amount of the supply, they do want to do tons of the hardware-specific optimization optimization. Perhaps it's working with the researcher to distill the model, make the model smaller. Perhaps it's doing tons of kernel compiler optimization all the way up to inference optimization in the engine layer. So there's a lot of things I think the infra engineers can do if they are really hardware-centric or hardware by design when they optimize the stack.
Yeah, it's interesting. So I think one takeaway there is it's very persona dependent. Like as Chi said, ultimately you almost want sort of liquid compute where you don't actually know under the hood exactly what's happening. You know the price, as Eugene said, what you're paying. You know the performance you're getting, the SLAs, and then you kind of are off to the races. But to Nicola's point, it's very complicated under the hood. It's a lot more going on than people probably appreciate to make these things work. Maybe just sort of related to that, Nicola, and maybe Chi can chime in as well, but just on the supply chain, right? We're all seeing the headlines, memory, power, data center site leasing and licensing is kind of bottleneck for the next 2 to 3 years. It seems like it's kind of the consensus view. Just maybe a comment on that. Like, what do you see as the bottlenecks, and what do you see of unlocking over the next few years to enable compute, if anything needs to?
I think on the hardware side, memory has definitely been a unpleasant surprise the last 6 months, right? Like this really drove the cost of the whole systems way up, and hard drives as well. Interestingly enough, sometimes now, basically the manufacturers have the GPUs and they're waiting for memory and drives and CPUs. So that's why the stock of Intel and Micron is.
So it's interesting. It's not really NVIDIA's kind of ready to go. It's all the other components that are
I think
waiting.
The interesting stuff is NVIDIA negotiated, I think, large supplies of memory for them, but that basically drove the regular memory or the regular drive like supply. And you kind of need these things to build a server out of them. So that's kind of an issue right now. Some networking components are high lead times. Generally, the GPUs are not as hard to get now. On the data center side, I guess it's tough because, as I explained, we need a lot more computing power, and the price of electricity is like gravity for the AI, right? Like if it's too high, basically you can't grow it at certain places. And there's many challenges, like where do you deploy these machines, how long it takes for a data center to get up. Like recently, the public perception about data centers has not been the best, which makes it hard.
Yeah, Chi, what are you guys seeing at Cerebras in terms of where you guys are on the stack?
Yeah, actually, not only us and everyone else see the same thing, right? If you look at chips from wafer into packaging and then to the different things nearby the thing, then you go to network gear, you go into memory, then you go to the data center, which is actually some of the special cables and also the transform actually doing the power, the cooling, the people doing the cooling, the site, the permission of doing the site, all that stuff is supply constraint. Like everything is 9 to 12 months backed out. If you haven't got your data center right now, you're talking about 2027, 2028. People are now talking about 28 because 2027 is gone. It's not pleasant because we got our stuff, but all the supply is not there. I have a take on this. I think part of the reason why we're constrained is it's a very sudden. The demand all of a sudden pulled out, and then everyone else is not responding yet. That's one. The second thing is the demand is not persistent because everyone's like, holy smoke, maybe it's just a .com bubble. Let's not build it. Right? Micron's a little bit worried, and everyone's a little bit worried. I think what's going to happen is for the next 2 to 3 years, if all the IPO happen, or the large economic value happen, then everyone's like, oh, I'm going to build this thing, and then we're probably going to overbuild a little bit, and then Musk's going to send us to space. Hopefully, we get more power. But for now, I think 2029, 2030, we're still going to be in a supply constrained environment.
Yeah, interesting. Okay. We're coming down to the wire here, so we're going to do one last quick big picture question, quick answers, and then we'll do a lightning round and wrap it up. Big money question. Where does the value accrue in this stack? Maybe, Denise, you want to kick off, and then a quick word from the whole panel.
Yeah, I think value really accrue at the top in terms of an agent layer and also at the bottom in terms of the chip and data the data center layer. So the reason why the top layer matters for all the quality AI agents, I think they're able to accumulate all the user usage data. The user usage, the user feedback data continues to be very important to improve the overall harness and also the model behind the scene. So it will really go through that continual learning phase to not only have a better experience, but also lower the cost over time if you can really fine-tune the model based on the user usage data. And at the bottom, of course, because the supply scarcity issue, any company who are able to improve the supply from providing more chips from data center perspective, from chips production perspective, to enhance the optimization so you can utilize the most out of the existing chips, I think these companies will accrue a lot of value as well.
So is that to say the models will not?
The model actually, though, a lot of time they also own the agents layer. They're full stack, so they actually get a lot of value from the first buckets as well.
I just want to quickly say that I think in an environment like this where we've discovered something that's really useful, I think value gets accrued in all the layers. Like NVIDIA is obviously making good amount of money. The data centers serving the models when it's constrained and doing it efficiently is great, and all the way to the top. I think for a while, it's good everywhere.
Yeah, I was. So my perspective is this is sort of the first time the intelligence is created not by natural birth, right? It's by something else. And then with this environment, then you're like, what will be the thing 100 years from now? My imagination is what is limited. Space is not limited. We have billions of stars and whatever in universe and trillions. And then energy is unlimited because we have so much suns and whatever. And then I think we will just populate all the general intelligence everywhere. So in that sense, I think where the value is if you are actually working with non-human intelligence that can amplify this thing, then you'll get value. But if you are restricted on the sort of biology body and how was human thing was working before, I think that will be a little bit issue because at the end of the day, this is just a sea change, right? I do wake up sometimes like, holy smoke, what am I going to do with Cerebus? We're just a little bit fast and everyone's get a value. And one thing I try to tell you guys is, I thought about it. There's one thing that is limited in the universe, which is time. So with that, I do feel like every second it counts. So if we can be fast, then we'll still have a space. Anyway.
What astonishes me is that less than 5% of the world is daily driving AI. We are still in the very early stages. My mom and dad barely touches it. And to me, the next big shift is when someone really solves getting for consumer AI space absolute reliability. We're talking about 99.999, where basically anyone could just trust it for day-to-day use. That will be the next major unlock because suddenly now everyone is using it for day-to-day tasks, and that will capture the front row of the value and trickle all the way down. Because obviously once you have that, whatever inference numbers you're seeing that's being overwhelming, it's not even 5% enough. It will explode.
Yeah, I mean, I second that. So I think it's pretty important that we get intelligence into more people's hands, and I think the way we do that is just bake it into products and make it really easy to use. Ultimately, the value here is that we can reduce people's cognitive load, right? So people have to just do less jobs that they don't want to do. Hopefully, at least, hopefully we still get to do the jobs we like to do. But,
yeah. Well, I appreciate that. I think we're out of time. If anyone wants to know, the last lightning question, which we won't do, was how are we running Inference today that will look naive or obsolete in 2 years? So if anyone wants to know, find the panelists afterward. But thank you guys, everyone. Please give the panelists a round of a hand.